Hey guys, we're going to look at page 27. So we will be turning this in for a grade. So let's make sure that we get this down pat. Newton's second law, all it says, let me select pencil here, is that force is equal to mass times acceleration. And once again, this is directly where we get our units for Newton, because force is a Newton. I guess I can't write up there. Is a Newton, and a Newton is equal to mass, kilogram, times acceleration, meters per second squared. And a Newton is a kilogram times meters per second squared. So force is equal to mass times acceleration, and we will abbreviate that as F is equal to M times A. That's the equation that we will go back to each time. So let's look at number one here. With what force? I know I'm looking for force. Will a car hit a tree if the car has a mass of 3,000 kilograms and an acceleration of 2 meters per second squared? Our equation, force is equal to mass times acceleration. I don't know force. That's what I'm looking for. Mass is 3,000 kilograms times my acceleration, which is 2 meters per second squared. All I have to do in my calculator is type 3,000 times 2, which is just 6,000, kilograms times meters per second squared, which is a Newton. What force, so we're looking for force, would be needed to make a 10 kilogram, so that's my mass, whoops, I guess it helps if I put 10, ball accelerate down the alleyway with an acceleration of 3 meters per second. So we're looking for force. Force is equal to mass times acceleration. My mass is 10 kilograms times my acceleration, which is 3 meters per second squared. 10 times 3 gives me 30 newtons. Number 3, what would be the mass of a truck if it is accelerating? So we're looking for mass. This one might be a little bit different. We're going to have to move some stuff around. Of a truck, if it is accelerating, acceleration is equal to 5 meters per second squared, and hits a parked car with a force of 14,000 newtons. Force is equal to mass times acceleration. I know my force is 14,000 newtons is equal to mass, which is what I'm looking for, times my acceleration, which is 5 meters per second squared. So anytime I have a variable, I want to get it on one side of the equal sign by itself. So I'm going to move times 5 meters per second over, flip the sign, multiplying becomes dividing. So I'm going to divide by 5 meters per second squared. So remember, Newton is a kilogram times meters per second squared. Kilogram times meters per second squared. So I'm going to do 14,000 divided by 5. It's going to give me 2,800 meters per second, cancels with meter per second, and I'm left with kilograms. All right. Moving on. What is the acceleration? So I'm looking for acceleration of a softball if it has a mass of 0.5 kilograms and hits the catcher's glove with a force of 25 newtons. So force is equal to mass times acceleration. Plug in what I know. I know that force is 25 newtons. I know that mass is 0.5 kilograms times acceleration is my unknown. Once again, I want to get acceleration on one side of the equal sign by itself. I move 0.5 kilograms over. We're multiplying over here, so when we move it across, we're going to divide by 0.5. Oh, kilograms. So 25 divided by 0.5 is 50. Remember, a newton is a kilogram times meters per second squared. So kilogram will cancel with kilogram. I'm left with meters per second squared, which is what I wanted because this is acceleration. All right. How much does a suitcase weigh if it has a mass of 22.5 kilograms? So remember, I told you anytime you see weight to write an F. So we are looking for force. Remember, weight and mass is not the same thing. Weight is the force of gravity pulling downward on the mass. So force is equal to mass times acceleration. Well, my mass is 22.5 kilograms. And I'm going to use the acceleration of gravity, 9.8 meters per second squared. Because that is acceleration pulling downward on the mass to generate the force. Force is equal to mass times acceleration. So force is equal to mass, which is 22.5 kilograms, times my acceleration, which is 9.8 meters per second squared. 22.5 times 9.8. 220.5 newtons is the force or the weight. 6. What would be the mass? So I'm looking for mass of a rock falling from the sky if it hits the ground with a force of 147 newtons. And I know that if it's falling from the sky, the force pulling it downward is gravity, which has an acceleration 9.8 meters per second squared. So force is equal to mass times acceleration. My force is 147 newtons, which is equal to mass, which is what I'm looking for, times acceleration, which is 9.8 meters per second squared. I want to get my variable on one side by itself, so I'm going to move times 9.8 over. When it crosses that equal sign right there, it becomes divided by 9.8. Put that in my calculator. 147 divided by 9.8. I get 15. 9.8 meters per second squared here will cancel with the meters per second squared in newtons. I'm left with kilograms. 15 kilograms is my mass. Find the acceleration. So I'm looking for acceleration of the stack of books pictured below. If the stack has a total mass of 1.5 kilograms. So first we got to find force. And we can do that using this free body diagram. I have 4 newtons total pushing to the right, 2 newtons total pushing to the left. Remember, if they're going in opposite directions, I subtract. So I have 4 newtons left. 4 newtons right minus 2 newtons to the left. 4 minus 2 gives me 2 newtons. The larger force wins, so 2 newtons to the right. So now I know that my force is 2 newtons. So I can plug it into force is equal to mass times acceleration. So force is 2 newtons is equal to mass, 1.5 kilograms, times acceleration. Move 1.5 across the equal sign so that acceleration is by itself. I'm multiplying on the right, so I will divide on the left. So 2 newtons divided by 1.5 kilograms. Put that in my calculator. I get 1.3 repeating. Newton is kilogram times meters per second squared. So kilogram will cancel with kilogram. I'm left with meters per second squared. That is my acceleration. Uh-oh. Not sure what I did there. Oh, I just scrolled up. Challenge, 3 kilogram model airplane. So that is my mass. Traveling at a speed of 33 meters per second. The operator then increases the speed up to 45 meters per second in 2 seconds. How much force did the engine need? So looking for force. Remember, force is equal to mass times acceleration. I'm looking for force. I have the mass, but I don't have the acceleration. So let's find acceleration first. Acceleration is equal to final velocity minus initial velocity over time. So initial velocity is 33, final velocity 45. So 45 minus 33 all over time, which was 2 seconds. 45 minus 33 gives me 12 divided by 2, which is 6. So my acceleration is 6 meters per second squared. I can now plug that in to my equation. Force is equal to mass, which was 3 kilograms, they told us that, times acceleration, which is 6 meters per second squared. 3 times 6 is 18. Kilogram times meters per second squared is a newton. You get 18 newtons. Please let me know if you have any questions, guys. I feel like this is pretty straightforward, and I will see you tomorrow.